Lesson 36, we are starting a new chapter on polygons. Now the polygons that we know are triangles, so the one with the 3 sides, and the quadrilaterals, so anything with 4 sides. So this here is really what we've been exposed to, right, as quadrilaterals. It's really kite, parallelogram, rectangle, rhombus, but we do go through these again for previous knowledge. And also, I'm wondering if I do have a page on, so those were all your quadrilaterals. And I'm thinking, no, I don't have one here for triangles, but we will go over triangles also. Okay, so if I'm thinking just pure and simple, perimeter, right? So what are we doing for perimeter? Nice and simple, straightforward. Okay, boundary of a plane figure. So that means when I'm doing this, it is simply just units of length. So for example, this one here, if I just want to have perimeter, I'm just adding up all the sides. So 2 plus 5 plus 2 plus 5. It doesn't really matter what order you put it in. And then my perimeter, right, would be 14. Now, in this case, let's say it happened to be all in meters. So my final answer would be in meters for perimeter, adding up all the sides. When it talks about area, okay, a little different here. You should have your basic formula. So is the measure of the surface defined by a figure? So in this case, it will be units squared. So you may have seen these 100 sets in elementary school, where it's the beginning basic concept of doing the area of something. So for example, depending on the shape that we have, we will go over this in the next couple of pages, is that if I just take, for example, a very simple, let's say it's the same rectangle as up top, right? My area of a rectangle is base times height or length times width. I would just multiply those up, right? 5 times 2. And in this case, this example would give me, sorry, I'm writing over the other chart here, 10, let's say it's centimeters this time, centimeters squared. Metric conversion also would be previous knowledge. This is something we will be going over, but when I'm talking about just basic conversion is what you should know. We're talking about this, right? So we do have 3 different measuring units, meter, liter, and grams, right? So liters would be liquid. You would have grams, which would be more like a powder, like a sugar, and the most common one that we use would be distance in meters. So we know that every single time, so for example, if you're at centimeters and you want to go to meters, you're basically every single time here dividing by 10 per section. I keep it nice and simple. I just say, okay, move your decimal over. So for example, for that first one, before, I don't want to do the square one here, but if I use that example, if I have 100 centimeters and I want to change that to how many meters, I simply go, okay, I'm going to go left 2 sections, or divide by 10, which is really divide by 100, but I can also just move that decimal over 2 spaces, so I actually get 1 meter in that situation. That is previous knowledge. We should know that, so we're going to practice more of that. When it's square units, one little trick. So that's just centimeters here. But what happens if this same question was area? It was squared. Little hint here, the fact that it has a little 2, you just double your zeros or double your spaces. It's as easy as that. So for example, I know that I have to travel 2 spaces, right? Like the top here. So if I put that in yellow, I know I have to travel 2 spaces, but because it's area, it's squared, I double the spaces. So in this case, it will look strange, my answer. So 1, 2, 3, 4. So my answer here will actually be decimal 0.1 of a meter squared. So sometimes we have strange decimals, but that's how it works. If you're doing the dividing by 10 concept, it's the same thing. But in this case, every space you are now dividing by 100 because really you're doing this instead, which is really 100. The bottom of this page just gives you a bunch of different concepts of measuring where you would see, like, when we would use kilometer compared to centimeter compared to millimeter. It just gives you a little bit of concept of how big something is or how small something is. But like I said, metric conversion we will use and we will practice a little bit more. Okay, if we go over our basic formulas that we should already know, working straight forward, not working backwards. Okay, we're going to be working them straight forward. Now, first of all, let's go over perimeter. Perimeter, add all sides up. So really, I don't need a formula for that, right? I could have some shortcuts, but it's definitely just adding all the sides up for perimeter. If I'm talking about the area of a square, let's go through the formulas per se, okay? So the formulas here, area, if it's a square, and we do use the letter S, which is irritating because it looks like a 5. So really the formula is side times side. Okay, so really it's this S squared. If it's perimeter, right, it would be S, your side length, times 4. Rectangle formula, I'm going to stick to the right language here. Rectangle is definitely length times width, or perimeter you would add up all your 4 sides, right? So length, length, width, and width, add everything up. So here being your length and here being your width. So I sometimes call it base and height. If we're talking about a parallelogram, this would be wherever your 90 degrees is, would be your base, and that is your height. So base times height. And if you're talking about, again, right, in perimeter, we're just adding up 4 sides. For the next one, for your triangle, doesn't matter what it looks like, isosceles, right angle, scalene, it's always the same. Base times height divided by 2. Perimeter, obviously, you're just adding up all your 3 sides. Now your base and height, be careful, your base and height always meet at the 90 degrees. So if it's not labeled like the first one, they have to give you something. There's your height, there's your base. Sometimes they actually put it on the outside, the height. That's really where your height and base is. Rhombus and kite, same formula. These are your diagonals. And that's where your formula comes from. So diagonal times a smaller diagonal divided by 2. If it's perimeter, okay, it happens to be side times 4 because every single side in a rhombus is the same length. So like a square, but it's been squished. So I would need this diagonal length and this diagonal length to go plug into my formula and just multiply, divide by 2. Same thing for kite. Okay, there's my 2 diagonals. Whoops, sorry, not 2. So you have diagonal, diagonal, divided by 2. Now in this case, I can't say times 4 because they're a little bit different. 2 of them are the same and the other 2 are the same. Right, so here these 2 are the same and these 2 are the same. So add up all those 4 sides. Again, diagonal is that line going through, right, making like a T in the middle. Then you have your trapezoid formula, which is your height, base plus base, a shorter one and a longer one, divided by 2. Again, here add up all 4 sides for your perimeter. And let's go label your height and your base. So once again, your height has to be given to you at 90 degrees. And your longer base here to here, and your shorter base from there to there. Now you know which one are your bases because they are your parallel lines. Sometimes we might have a trapezoid looking like this. Okay, because it's sitting here, doesn't mean that's your base. Your parallel lines are your bases, okay? Sometimes the pictures get rotated around. And that 2, add up your b's, height divided by 2. Now circle we've done, right? So we know this. Area is r squared. Perimeter is a fancy word for 2 pi r for your circle formulas. Last page is going to manipulate. It's bringing in your equation skills and your basic formulas that we should already know, okay? So we're going over these formulas and working them backwards. So in this case here, right, they're giving you all these numbers. So this is the information. They're not asking you to find the area, they're giving you the area. So that's why you're going to be using these baby formulas backwards now. This is where your equation skills come in. So what shape is it? It is a rectangle, so use the right language. Length, width, maybe base height is often used there too. Area is 48. Your length is 12. And you are looking for your missing width. So that's like my X. Remember, maybe it looks nicer if it looks like this. Flip your question around. We were so often using X, but now actually X means something. It's W. Remember how my equation skills? Divide by 12 on each side. X is equal to 4 as a final answer. So yes, I know you can just divide by 12, but you are setting up an equation because formulas are going to get more complex as we go through. This one here, use your famous square root button. So if they're giving you the area of side squared, right? So area 64, your side is basically your X. And remember, the opposite of squaring something is square rooting the other side. We saw a little bit of this when we looked at circles. X is equal to 8. The next one is parallelogram. That we always use base and height as language. My 142, same thing as my above formula, right? This time I get my base is 20 and my height, sorry, opposite. You're missing the base and your height is 20. Okay, we're used to seeing this clean algebra with 20 in front of the b, but it doesn't really matter. You guys should know that this is exactly what it means, and what do you need to do to get rid of it is to basically do the opposite. So divided by 20 on each side. And when I do that, 142 divided by 20, I get, is it 7 point? I don't have my calculator out here. Where's my calculator? Give me a second. 142 divided by 20, 7.1. So my base, 7.1. Obviously, I would have all my measuring units here, which I'm not focusing on right now, okay? Then your next one, you have your triangle, your formula. Always write your formula. If you don't write formula, I'm penalizing you for that, okay? So, because chances are if you're making a mistake, it's because if you wrote your formula, you would not make that mistake because it's pretty straightforward. Here my A is 9, my area is 9, my height is missing, but my base is 7 times height. Now don't forget your 2, a lot of kids will forget 2. Now simplify, okay? You could either bring that 2 over by multiplying each side by 2, but I think most students would get rid of the 7 and the 2 right away. So 7 divided by 2, 3.5 height, and now it looks a lot like your parallelogram. Divide each side by 3.5. Your height there, okay, so 9 divided by 3.5, 2.57. So your height, 2.57. And you can always plug that in to test your theory. So if you go back and I'm just going to check to see if I can get my calculator here yet so you guys can see it. So I'm going to test my theory. 7. Okay, 7. It's not letting me take my number here. Hold on. Yeah, not cooperating with me. 7. So I'll do it on my other calculator. So what you should be doing is, to test it, 7 times 2.57 divided by 2 gives you, well, on my calculator, 8.995, which rounds to 9 when I'm asking you to round to 2 decimal spaces. So my height is actually correct. Rhombus or kite, same formula, right? So let's go write that formula down. Diagonal times diagonal divided by 2. Fill it in, 132. And I have one diagonal is 12. The other one, doesn't really matter which one is which because they're both just going to be multiplied. And so same thing as my triangle, right? So 132, I can get rid of the 2 and the 12 right away. 6 diagonal. And my last step, divide each side by 6. So I get 132 divided by 6. I get exactly diagonal is equal to 22 in that case. Your last one is your trapezoid. Your area trapezoid is height, base plus base, divided by 2. I will have a green formula sheet that has all these formulas on here, okay? Now 2 never changes. Whoops, they did give me the area, so let me go back and erase that one. My area is 45. My height is missing. Your base plus base, so 9.8 is your longer one and your shorter one is 5.2. And then you can keep on solving that. So let's simplify algebra on the right hand side. So I would definitely go pick on adding up these two, definitely. So if I could estimate 14, add that up, gives you a 15, and then it looks exactly like a triangle formula, or the diagonals, the kite formula. I would definitely go cross these two out. Height times 7.5. Your last step, divide each side by 7.5. Your height in this case, 45 divided by 7.5. It actually gives you a perfect height of 6. And that's it for this video.